And now, ellipses. All right, so in the last video that I put up, I was talking about circles. And I was trying to explain why the standard form of a circle is the way it is and what it does. And if you don't remember it, it looks something like this. Go back and check that video if you didn't see that, because it's gold. X squared plus y squared equals r squared. And we were relating in that video, why does it look so much like a squared plus b squared equals c squared? In fact, how is it not just the same equation in a way? And those are great questions. And if you want answers, go check out that video. But in the meantime, we're moving on. We're taking this, and we're going to see how this applies to this, to that ugly mess. If we're talking about ellipses now, I mean, what's changing here? What's really changing here? Let's think about what an ellipse is, and then we'll figure out the rest of this. This will be easy once we get what is an ellipse. Looks something like this, right? I mean, it's an oval. That's all it really is, right? You've seen ovals. There it is. I like when I can empty it out. There we go. It's an oval. There's only so it's an oval of a sort. Let me try that again. It's definitely an oval. It's a circle of a sort. A circle is, in a sense, a sort of ellipse, and an ellipse is sort of like a circle, but it's really not either. What makes the difference? Well, here's one thing. For one thing, we don't have just one radius to talk about. In fact, before when we were talking about circles, we were talking about how I can get this to work. Yeah. Okay. We were talking about if I have, so there's a radius, right? But I can't say the radius anymore because that doesn't make sense in this context anymore. So let's say I take the radius, and if I try and spin it around the circle, around the center, I should say, along the circle, as I did in the last video, of course, I'm trying to keep this radius the same length. I come all the way up and bam, look at that. Absolutely off. That's the whole point. Now, your intuition gets this. You're like, why are you showing me this dumb display, this demonstration, Kelsey? Because I want to make a point. We've got to change the way we've been thinking about ovals and circles and such sometimes. And so here's the point. The point is we're going to use two radii to talk about this. I imagine this. This is where it's going to get awesome, by the way. What happens if you were to divide by that, right? So imagine, let's start out with just a normal circle again for a second. Normal circle. This is our little dummy circle here. And I want you to be empty again. Empty in your soul. Okay. Stop moving. Okay. So what would it mean for me to do the following? If I divided both sides by r squared, nothing will have ultimately changed, right? This will just become 1. That just cancels and becomes 1. And I can separate this fraction into x squared over r squared plus y squared over r squared equals 1. All of this is still just describing a circle. However, now that we've got it in this newfangled form, we need to think about this because we've got a new kid in town, and I want my green back. Where's my green back? Okay. The new kid in town doesn't have one radius to speak of. We're going to talk about two radiuses. Radii instead. Multiple radius. And by the way, don't say octopuses is octopi. That's not a thing. It's octopuses. I checked. It's Greek. I think it's actually still for debate. I am the last person who should decide if it's octopuses or octopi. But I'm just like, I'm too perturbed by the issue. Perhaps just that maybe I'm perturbed that so many people care that deeply. I love octopuses, by the way. I think they're really cool. Okay, you did not come here to hear me talk about octopuses. We've got two radii now. And so what does this mean? This means we're going to take advantage of what we understood before, and we can think about this in terms of triangles and all that other jazz. But we first, I know I can make straight lines. Maybe if I press down on the pen. Is that how it works? Not even close. What if I use the little, oh, now it's not even erasing stuff. That's fun. Okay. I had to do that manually. I guess I have to do all of it manually. Oh, button doesn't work. What does this button even do? I don't know what that button does. Sorry, guys. So you can imagine another right triangle in there and stuff, but this is starting to get convoluted, isn't it? I mean, wasn't the whole point, Kelsey, that I could find some given point with a right triangle and all that? Yeah, it still all works. The problem is that you have multiple hypotenuses. Oh dear, now somebody's going to go look up hypotenuse and figure out if it's hypotenuse, hypoteny. I'm going to stick with hypotenuses, I'm sure of it. We have multiple of them. We could have, if this were if this were hypothetically the same length and they're not, this would be, oh, sure. Okay, so I just hold it down and it becomes straight. That's cool. Anyway, so that would be one of them, right? So there would be one right triangle. The problem is we've got another one over here too now. And if that one were, to be, I'm going to write it close but not be exactly the same. If that were to be drawn out here, then it would look like this. I held it down. It didn't do it this time. Come on. Holding down. I'm holding. What's the trick? What's the magic? What is it with you, graphics pen? Oh my gosh. Okay, hold on. I know there's a way with, if I hit shift, I'm just trying to hold the mic at the same time. There we go. So which of these do I trust? If I'm trying to find the point, is it some average between the two maybe or something like that? We can get into a lot of hypothetical stuff here, or we can actually do some derivations and stuff. But that's what we're going to do instead is we're just going to recognize that this is following the x-axis again, and we want this one following the y-axis, and it's almost like a minimum and a maximum value. For this particular ellipsis, this is not always the ellipse. For this particular ellipsis is a series of dots, guys. Don't fall for my late night rantings, my terrible vocabulary at this time of night. An ellipse that looks like this, as opposed to an ellipse that's standing up and down. So the egg is lying on its side instead of sitting straight up. Is going to have a minimum value for the y and a maximum value for x. We'll see when it comes to more stuff later, particularly with the other conic sections, why that's important. And it's important. It's important to remember that because we'll have to be concerned about minus values and stuff. Subtracting and so forth. But for now, we're good. For now, we should be okay. So let us continue. So in other words, we have this going on, but because we're no longer concerned with a circle, we're concerned with that guy, we're going to change the business. We're going to say, okay, click and delete circle. There we go. All right. So what does this mean now? Now that means let us call these. This is, of course, just my fancy way of saying, the initial radius and another radius, so R0, R1, and that's what we're going to do. We're going to rename these. We're going to call these R0 and R1. And we now should be aware that R0 does not equal R1. That is what makes an ellipsis an ellipse. I said it again. That is what makes an ellipse an ellipse. So what we're looking at here now is a standard. This is the standard equation for an ellipse. And you might be like, no, this is ridiculous. I know, Kelsey, it's in my textbook as this. ax squared over a squared plus y squared over b squared. You lie. Well, hopefully some of you are a little bit more fine-tuned than that. I could name this pi. Not pi. I'm not going to use pi. I could call this dog squared. It's just a name. It's just R0 is A. R1 is B. I could call them whatever I want. I could make this x squared over tarantula squared plus y squared over, your aunt's mother's nephew's whatever squared. It's not important. They're just names. They're placeholders, as long as we're being consistent with how we're using them, we're fine. So use this, that's fine. This is also the standard form. They both work. The important thing is, even in this scenario, if it's going to be an ellipse and not a circle, A cannot equal B. That's it. So if that makes you feel better, then sure, let us change R1 and R2 to A squared and B. I'll just make everybody's day by erasing all that, and now we can call this I'm doing it again. Just said I wouldn't do that. A and B. But I want you to see how all that's going on here is this. It's a circle. I mean, it's not a circle, but it's derived in a sense from a circle, where we would just consider the radius of the circle under each of those coordinates, and under X and Y, and we'd be just in the same position as before. But since the radii are not the same length, now we can do fun stuff. Now we can actually find coordinates for these things, missing values and all that other jazz that I mentioned in the last video. This will all be very useful to us. This is good. This is good. Okay. Enough on that. That is the standard form. Now, what do I do with this? How does this help me? How does this help me solve this? It says define the... Now, I'll stick some stuff up here. I went ahead and a couple of days ago and, let's see, ellipse problem formula. Yeah. Just went ahead and did this. And it's not pretty. You have to forget... Oh, gosh. Look at that. I even put a minus sign in there. It's not pretty at all. All right, well, let me change that. And you'll see some additional variables and stuff in here too. Like, oops, that's not what needs to be changed. This, there we go. All right, plus, all right. So there's some extra variables in there. Might be like, what's that about? So the extra variables H and K are what help us figure out the center. So when we were doing the standard equation for circles, x squared plus y squared equals 1 squared, and we were talking about how to find the center, well, you can just think of it as x minus h squared plus y minus k squared equals 1. This is also the standard form for the circle. They both are. The only difference is I'm being a little bit less discerning here of where the origin is at the given moment. But if we need to be really specific, and sometimes we do, sometimes it's not the origin is not, or the center is not at the origin, then we need to be clear that it's being subtracted. So if the center is at, say, center is equal to the 300 and negative 126, then we want to plug in 3 here, so that'll be x minus 3, and then we would be plugging in negative 126 here, and there'd be y minus negative 126, or y plus 126. Same business is going on over here. The same business is going on over here. I almost feel guilty that I didn't put that minus h minus k business in the last video, but I don't think I do. And I don't feel guilty at the moment. I don't know. Maybe I'm too tired to feel guilty. Let's find out though what to do next. So we know why this is the center now, hopefully. If it's not clear after the last video and this one, just there's nothing more to say. It should be clear. Go rewatch them if it's not. Horizontal radius. This makes sense, right? We talked about what this means. This is our R0 as it was before, and our R1 as it was before. And we're really just concerned about this being on its side right now. If this were up top, it actually wouldn't. The only thing that would be changing is which is the minimum and which is the maximum length radius, but it wouldn't be changing. Nothing about the formula itself would be changing terribly much. This is also brilliant. I love this. Did you see my other mistake? What the heck is that? That's supposed to be a Y. It's supposed to be a Y. I'm deleting this image. Right now. This is a terrible attempt at to make life easier for myself. I did not. I failed. Do I get white? I don't think I get white in this program. So, okay, this is fun. We'll just, yeah, there we go. Boom. Butchered, but done. All right. Y minus k squared. All right. We've got everything we need. So this center, vertex, focus, etc. We're not going to get into foci today. It's not asking about foci. We can talk about focuses, foci, definitely foci, radius, radii, focus, foci. We're going to talk about this next time. But what do we mean? What the length of these matters? You may be like, what? Who cares if it's a minimum, maximum length? Which ones we call, which points on the circle we call the vertex or vertices, and which ones we call co-vertices matters. So in this case, because this is the longer one, and imagine this thing we're going all the way across, right? These are the vertices. So the first, there's a vertex here. There's one here. Let's just go on and put some little coordinate point brackets around here, because these are questions we have to answer. Imagine we have to fill in these. There's going to be a co-vertex here. B is shorter. So it's kind of like, imagine the head honcho is the longer one. Big guy has got to be called a vertex, and the buddy, the little sidekick with the shorter, always shorter. Robin's always shorter than Batman. If Robin had been taller than Batman, it would have made no sense. Nobody would have watched that and taken it seriously. This is the co-vertex, and then both together, the co-vertices. We got to fill in those blanks. They also want the center. And by this point, you should feel so comfortable with figuring out what the center is, right? Boom, boom. We saw how this works. We know then we should just take the numbers from inside there and flip the sign, and we're good. Center is equal to 2, -1. And just be careful if the problem presents it, because this is, this is a plus sign. So you could commute here, and this whole part could be over here. They could do it backwards. Say y plus 1 squared over 81 plus x minus 2 squared over 100. They could do that. Whoever makes your test or whatever, they could do that, and it'd be fine. So just be careful. Make sure whichever one is in the same box with x, that's got to be your x coordinate, right? And wherever's in the same box with y, your y coordinate, that makes sense, right? Shoes go with shoes. Blouses go with blouses. Glasses, how, whatever. I don't wear any blouses, if anyone's asking. Okay, moving on. We've got the center. What about the rest of it? You could just again, follow this. Just follow what I've got here. But I want to also reason our way through it just a tad. So if A then is going to be that, it's not going to be that in its... that can't be A, right? That's the point. This is A squared. So if that value represents A squared, we know the square root of that. This is the same thing as 10 squared, right? The root of it's 10. So A has got to be equal to 10, which is not one of the questions they're asking, but that'll help us solve this, won't it? So this has got to be 2 plus 10, or 12. And we can go on and do 2 minus 10. Try and write -8. Bam. Done. There. That was not bad. And since we are here, let's just get all the x's, because if we know what the center is, and we know that this thing is directly above and below the center, if you're not sure why it would be directly above and below, I want you to just sort of pause and take a moment to deeply reflect and intuit why that would be the case. Why would it have the same x coordinate? Why would the topmost point... It's a little hill, topmost point should be aligned with the center. So those are both 2. Great. 81 is what squared? They made this nice and easy for us. Nice, easy numbers. We could have had a much worse day with this. 9. So B has got to be equal to 9. Okay. So if I start from this y coordinate, we're going to go 9 up. So -1 plus 9 is going to be 8. And -1 minus 9 will be -10. And guys, this is it. We have got the center. We've got, oops, getting ahead of myself. This is when you look back on the test and you realize you got points off because you didn't finish your work. -1 Same reason that this is the same y as y these up here were the same x's. So these are the two covertices. Now here's one thing. I'm saying we're done, but the truth of the matter is if you don't label these on the test, you're probably going to get points off. So don't foul up and fail to mention which is which. So I'm going to go on and label them the covertices. And if you didn't draw a picture, that's fine too. Then just write covertices colon blah blah. But I like pictures. I like them. They make me happy. And I actually understand things better when I see them in picture form. We all say we're visual learners. I'm doubting that, but I do think visual is a nice supplement to other things. And if I need to like explain what C means to somebody, then they've got another thing coming. All right. Good work.